Hello everyone and welcome to another Python fundamentals training. Today we're going to be talking about operators, and when I mean operators I'm talking about the plus sign, minus sign, multiplication sign, division, modulus and stuff like that, and how they work in Python. And we're going to do it at the simplest levels. We're just going to we're not going to use no complex container types. We're just going to use regular variable data types, the base data types, to go through just these examples. But I just want you to have at least one video that covers just general how to do operations using Python. And the last thing we're going to cover is control structure. Specifically, we're going to look at the if and else, because I don't think up to this point I have ever said anything about the if-else statements and stuff like that. And we're also going to look at what else? If else, and we'll probably look at the while statement. I think I've done the for loops. That is a control structure, but we've used those in every example up to this point. So just in this example, I won't talk about the for loop, but I will talk about the if and else and while loops. All right, let's get started. Let's get it. And here we go. All right, so first we're going to instantiate a couple of variables. I'm gonna call this variables for this. So I want a variable, we're going to use just letter variables, make it easy. So I want A to equal, let's make up, say 5, B is equal to 15, and C is equal to 30. Okay, just write these out. And then I'm going to want, so those are my three numbers I'm going to use for the examples. And I want to use three strings, and we'll call those X, Y, and Z. So X is equal to, I just use my name. I know y'all getting tired of me using my name and my family names on a lot of things, but that's what I think about when I'm writing at this point. So Michael, Andre, and Hamilton. So we can just have three strings and three numbers that we can work with. So I haven't ran these yet. I just wrote the scripts. Remember, the left side is just like a text editor. So to get it stored into my memory, I shift enter all of these, shift enter, enter, enter. I'm holding shift down, by the way, to run each line one at a time. So we have the three numbers at the top and the three strings at the bottom. All right, so addition is the first operation we're going to talk about. If you add two numbers, so if I say A plus B, it's going to do what you think it is. It's 20, right? So 15 plus 5 is 20. Okay, so if I say A minus B and do shift enter, it's negative 10, right? Because 5 minus 15 is negative 10. So this is addition. This is subtraction. Now also for addition though, did I spell it right? Subtraction. Yeah. Also for addition, I'm sorry for that. Also for addition, if you add a number or two strings together, and I talked about this in a early video for strings, you end up just connect what they call it, concat them together, right? Concatenation. So it just takes the string 1, string 2, or the string 3. If I said A X plus Y plus Z, it's just going to put them all together. So to get it to do it right, I told y'all about using a quotation for a space. I'm gonna do it this time, so I'm gonna call it like spacer is equal to the quotations. You don't have to do this, but just having this as an object might make it make more sense. So now if I want the space to be for the name, I could say X plus the spacer, okay, plus Y, then plus the spacer plus Z. So you can see what I'm saying. So now when I do shift enter, so the difference is this one down here, it doesn't have the space. So the spacer just adds a space character between the X, the Y, and the Y. And that's how it does it. Now the reason why I created a spacer is just to show you kind of in general what's happening. You can assign a variable that represents that space and then use that variable for the plus sign for the strings. I don't normally do it this way. I normally don't create a variable just for a character, like something like this. So for me, I will replace the spacer one and just put the space there. So this is kind of how I would normally set this up. I wouldn't have a variable doing this unless I have a whole bunch of these to create, maybe. But for the most part, I would do it this way. So if I do shift enter here, it's going to give me the same results. It's just the difference is that I didn't create a variable for access to this memory item, this memory reference item. Because you remember I told you before, this sits at a memory location with a reference point. This is just a reference to this when we're talking in general. All right, so for adding two numbers, subtracting two numbers, you can do that, but you can't just subtract strings. I'm gonna be honest with you, I've never even tried. I want to see what x minus y does, and it does nothing. I didn't think it did, but you only can concatenate and you can multiply. So let's talk about multiply. So if we want to use multiplication, all right, so a times, it's the asterisk symbol, a times b is 75, or b times c is 450. So 5 times 15 is 75, and 15 times 30 is 450. But if you multiply a string, it just makes a copy of it. It just makes multiple copies of it. So if I say x times a, what's going to happen? It's going to multiply Michael 5 times, because a is 5. So you're going to have 5 Michaels. 1, 2, 3, 4, 5. So when you multiply a string, it just makes multiple copies of that string based on the total count that you have. And then to divide two numbers, division. Okay, so if we're going to do a divide, all we have to do is, let's see, b divided by a. Just use the slash command. I think that's the right one. I think it's the /. Yes, b divided by a is 3. So 15 divided by 5 is 3. And also you can say c divided by a. That should give me a whole number as well, 6, because 6 times 5 is 30. Now, you do have a couple of other divisions. You have modulus division, where it returns back the remainder. So if I say, let me type it in, modulus. So if I say b, and then I think it's the percent sign a, when it returns back, it's going to be 0. And it's going to be the same for c as well, because is it c divided by a? It all returns 0 because the remainder is 0. So let's do a little basic math to make sure we all on the same page. Let me open up my Paint app. So when you say 15 divided by, what did I say? B divided by A. 15 divided by 5. So you got 15 divided by 5, you know, what goes into 15, you know, 5 is 3, you know, it's 3, right? 5. So that'd be 5 times 3 is 15. Old school way. I don't know Common Core, so unfortunately, that's not how I would do this. 0 is the remainder, and this is what's being returned to the, so this is what's being returned in this part of the code here. So it's the remainder. So for instance, if I were to say, which one won't give me a perfect, I think all of these, let's create another one up here called D, and D is equal to 7. Okay, I did shift enter, so we got D. So I want to say C divided by 7, right? So if I do C modulus D, shift enter, I get a 2. That means that the remainder must actually be 2. Okay, so if we go work this out, if I say C is 30, right? 30 divided by 7. Okay. how many times. So you know 7 times 3 is 21, 4 is 28, right? So 7 times 4 is 28. You do the 28, you subtract, you're left with a 2. So this is the remainder. This is what is returned. Now there's also what is it called? I think it's called integer division. I don't remember its official name, but what it is that when you do regular mod, you get the 2 back, but you can get the first number, which is the 4, and this is called, I think it's called integer division. But to do this, you just need 2 backslashes in your code. So if I wanted to get the 4, we go back to the code, and if I were to say C double backslash D and do shift, the results is a 4, and it's a 4 because it's returning back this portion. The double backslash returns back the integer part of the equation when you do the division, and then the regular mod just returns back the this one is that one. This returns back the remainder portion when you do the division. So it's very useful. I'll probably show you an example with the control structures using it. To be able to get the remainder or to get the top number for some type of algorithm. Alright, so that's the divisions and how to do the divisions. Alright, comparisons. You can do comparisons that returns, let's see, let me type that in, comparisons, yep. You can do comparisons to see if it's true or not. So like the results of comparisons are going to be Boolean values. Either they're going to be true or false. That's pretty much what comparisons do. And these comparisons are necessary to these comparisons are necessary to set up control structures as well. So like you need comparisons for control structures and loops, and that's the main reason why you have them. Other than you might just want to know what's true and what's not in that relationship between the data point that you are comparing versus the container type that you're going through. In this case, the container's size is 1, so we're just doing a direct comparison between 2 variables. All right, so if we wanted to say A is less than B, shift enter, that's true because A, which is 5, is less than 15. If I were to do is A is greater than B, A is greater than B, that's false because A is not 5 is not greater than 15. Or you could say A is equal, and that requires 2 signs, B, and that'd be false because they're not the same. This is very important. One thing I can tell you, one beginner mistake that you'll end up doing is using 1 equal sign, thinking you're checking for a comparison, and you actually assigning that value to that new value. I don't know if Python stops you from doing that, like in a loop, but I know like in C++ you can do that, and that mistake will be carried out, and there will be nothing to tell you about it. So I'm not really sure about how the IntelliSense in Python works in regards to about that issue. But just always remember, when you want to do a comparison, it's always 2 equal signs, not 1. 1 mean assignment. All right, keep going. So that's pretty much the comparisons, and it works the same way with strings, except it's looking at the string count. So for instance, if I said if A is if X is greater than Y, it's true. That means that X, which is a size 7, because my name is 7 letters, 1, 2, 3, 4, 5, 6, 7, is bigger than Andre, which is a size 5. So it's checking to see the links are the links are the same. So that's true. So X is less than Y is false, and then X is equal to Y is false because they're not the same. So this is a way to do different types of string comparisons, as well. Oh, I forgot a couple. Is A, you can also, I forgot about the not symbol. I forgot one that we didn't talk about. So you could say A, not just less than, you could say not equal to. So like X is equal to y is not true, right? But x is not equal to y. That's true because they're not. So the not is checking the opposite of what it is here. So you're saying, is x equal to y? No. But is next not equal to y? Yes. So that's kind of what it is. And you can use that for any of the equal type clauses. So like you could say if a not equal to b, that's true. That should be true for all the numbers because none of them are equal. So this will only be false if two numbers or two strings were actually equal. So we did string comparisons. Okay, logic. So for instance, this is a good way to talk about it. These outs are returns. So like these are the out for any of these comparisons is a Boolean. So they technically, I was going to talk about Booleans now, but I'm gonna start while talking about Booleans from the perspective of that the return to these comparisons are Booleans. So for instance, if I had a variable called result, I'm just gonna say that's result, and I want to say I want to store what is a less than b. Okay, so a is less than b. If I shift enter this, I'm gonna get a value here called results, and you see it says it's a Boolean because what it returns is an actual Boolean. So this always return a Boolean. So that is what's being used when you try to check if some type of control was actually true or not, like when we do a control structure. I think the best way to talk about this is actually talk about this right now when I keep saying that control structure part. So say a control structure is like an if statement, like if this is true, do something, else do something else. So for instance, what if I wanted to see if a is less than b, which we know is true, print out on the screen that this is true, else if it's not true, it prints out it's false. Okay, so if, then I put that expression, the expression we're going to use, we're not going to put this because this is what it returns, the expression if a is less than b. So there's a keyword called if, and then you put the expression, and then once you have the expression, you use a colon and then press enter. This tab is important. Like this tab says that anything written here is part of this if statement. If I do all the way backspace, if I wrote it here, this will cause an issue because it wouldn't take into account of what's going on in the if statement. So I said I wanted to print. This is true. Remember I just said that, and you notice it's giving me an error. It said expected and an indented block because it should be tabbed over, because it knows that it's trying to warn you that it knows you're trying to do this action inside this if statement, but you don't have it set up correctly. So if you press the tab key, the error goes away because now this print statement is tied to this if statement. So if this is true, and it says if this is true, this expression is true, which we know is true because we stored its results earlier. Its results is true here. If this is true, print this. Else, I can press enter. Else, the colon. When you put the colon, it's going to back it up to next to the if because it knows these are together. So you put another degree, say print this is false. Okay. So now when I run this line of code, right, shift enter, you see this is true is printed because it did a check. If this expression is true, which means we know the result is true because I stored it here, go and read what's in this part of the code, which is this part. Else, which if it's not true in this example, because there's only one type of if else, go and read this part. So if I were just to change this symbol around, just say this is great, a is greater than b, we know this is not true. So when I highlight the whole section of code and then shift enter, this is false. So this part here is reading out because if check the condition returned false, so it branches to the else statement and then it prints it out. Okay. since we're on this topic, I want to add one more that's equal so we can show a else if statement. So what if we did have E up here and it was also equal to 30? Okay, so E is 30. Shift enter, so they're the same. So say if we want to update our function here to deal with that case, we need what we call a else if statement. I think it's ELIF. It stands for else if, but it's ELIF keyword. So what I'm gonna do here, I'm gonna go to this spot, I'm gonna press enter right behind the first if, and I'm gonna do ELIF, and then I will create my new statement if let's see. So we're gonna do all three checks. So right now we have if we're gonna change this to C. Let's change it to C and E so we can actually see the example. So if C is greater than if C is greater than E, okay, it's gonna print this is true. We're gonna change this to this is the first number. I'm sorry, I'm like rambling a little bit. The first number is greater. Okay. And then on the else, we're going to check if else if C is less than E. We're going to do the colon, semicolon, it brings it back. So I want to print the first number is less. Sorry, real time, just trying to come up with some things. All right, and then for the last case, I'm going to do another else if C is equal to E. I want to print the numbers are equal, and then if none of these conditions, a lot of times you'll just have an else. So this condition would be called when all the other conditions fail. I'll call it all other conditions failed. Okay, so we have a case where when C is greater than E, it will print the first number. C is equal to E, it'll say the numbers are equal, or less than, it'll tell us if the first number is less than greater, right? So right now we have C and E set the same. So if I run this line of code now, it's going to say print out the numbers are equal, because this was false, but this was true. So it printed this out and it didn't have to run this statement. So if I were to go change, C to be bigger than, so if I made C up here 31, which is what I'm doing, one change, make it to 31. And now I just want to rerun this piece of code here and do shift enter. Now it says the first number is greater, and that's true because 31 is greater than 30. And if I say this one is 34, E, I changed E to 34. I go down here and rewrite this, rerun this same line of code. Shift enter. Now it's saying the first number is less because C is less than E. So this is pretty much a control structure, and all it means is that you have a way that when data is passed, it knows where to go based on some comparison or condition statements. So remember I talked about another comparison I've shown all the way almost through every data type when I was doing the data types was the membership comparison, where you had a list or a dictionary or a tuple and you wanted to say if this value is present in this list and it returned back true and false, you could do that. That is a comparison statement too. So you can use that comparison to check to change your data path, branch your data differently as well. I'm not going to show it in this example, but that is what the whole membership class is for. to give you the true and falses if it's true, so you can go subset your data or do something else with the data. Okay, so I did that for a while. Okay, I want to talk about assignments operations. That's very popular, where you can update a assignment to a variable by using operations. Assignment operations. So for instance, we have a is 5, right? A is 5. What if I wanted to add a to 5, a5 to a? So one way to do that, I could create a variable. There's 3 ways, but there's the easiest way is the last one. One, I could say I create this temp variable. Temp variable is equal to 5, because that's what I want to add to it. And then I would say a is equal to a plus the temp variable. Okay, and that would give me 10. Okay, so that's one way to add 5 to a. Another classic way of doing it is just, you remember I told you that in code it does the things to the right first before it does the assignment. So you could say a is equal to a plus 5, and the reason why this works because Python is going to compute this first and then it's going to assign it to it. So when I run this, it changes to 15, right? So we went from 5 to 10 to 15. All right, so this here is such a common thing to do that there is an operation for doing this. So when you want to just take a variable and then add something to the variable and restore it into the variable, you could do it with this syntax. A is equal to plus. Is it equal plus or plus equal? I think it's plus equal. Plus equal, yeah, 5. So this does the exact same thing that this does. So now this is saying a plus 5, take a and then add 5 to it, and then this will equal that new value. So if I run this one line of code, now you'll see a went up to 20. If I were to run it again, 25. If I were to run it again, 30, and it would keep going up by 5s forever. Now the cool thing about this type of operation, it works for all the base operations, like operators. So I plus, minus, divide, and subtract. So say we got it up to 30 on my screen, so I have 30. So now I want to divide it by 5, so I could just say the divide sign equal to 5, and now my answer is 6. Switched it to a float, but it's 6. You see that? And then say if I want to subtract 2, I can say a is equal to minus equal to. Now the answer is 4. Okay? And then whatever I did. Then I want to multiply that by 2. So I can say a times equal to. And now a is 8. So this here is these syntax is what assignment operators are. This here is very popular way of seeing it. So when you see this in code, that's what's happening. They just got the shorthand for making changes, and you might see this in loops, like counters, like a counter index. They might have it in a loop where they want to jump by 2 instead of going every for loop, every different iteration. You might want to go every 2 object items. So you can set your counter to change the index in which it's looping through. So that's another advantage of using assignment operators. I think the only thing I didn't show you, I did say I'd show you an example of using the modulus. So say we wanted to figure out if a number was even or odd. That's like the most classic way of using it, the modulus. You know, if a number is even, it doesn't have a remainder, so it's 0, right? So if the number is odd, it has a remainder. So that simple check, instead of having to go through and see and keep up with a table of even numbers and all of that stuff to figure out if the number is even, by just using the modulus check, you're getting back what you need with probably the minimum amount of runtime required to do the task. So I'm gonna use it for just the A example. So if A mod, I think I have to mod 2, yeah, like, you know, every even number is divisible by 2, right? That's a good example. If mod 2 is equal to 0. It's like that's the condition. I'm checking to see, does this return back a 0 and do they equal? If this is true, colon, then I'm going to say this number is even. Okay, and then I can say else. I don't even have to have a condition here. Print this number is odd. All right, so we should expect that A is going to be odd, right? So when we run this line of code, oh no, I'm looking at the wrong A. The A I should be looking at is the one stored in memory. So A is actually 8 right now, not 5. So when I do this, run this piece of line, it should return back that the number is even. Yep, the number is even. If I were to go convert A back to its original number, shift A here, and then go back down to the piece of code I wrote down here, rerun this piece of code, highlight it, shift enter, and then now the number is odd. So again, that's like a case of using mods to actually do something. And then the last type is the control structure I want to talk about, is the while type. And so the while type control structure is going to do something until the condition has been met. So you put the condition up front, and then you do what you said you want to do, and then once it gets to the condition, it will stop. So for instance, I might have I want to like print out, I don't know, my first name until the condition loop has been met. So say if I want to print my name 10 times, so I might have like I'm gonna say condition is equal to 10. That's how many loops I want to use. So while is the key word, and then I could say while, let's see, I gotta have something to loop through. Let me make a indexer. So remember I talked about a counter. So I gotta create a counter. So this counter is what's going to keep, it's going to check. I'm gonna say the counter is 0, just to keep the 0 indexing. What the counter is going to be used is to update using this operations here to let the to update it, so the while loop knows when to stop, because we said the condition for the while loop is 10. And the counter is going to be 0 at the beginning, but each time we go through the counter, we're going to have to update the counter itself by 1. So it'll keep printing out my first name, which my first name is in X, right? X, yep. It's going to print out my first name until that condition has been met. So while the counter is less than, less than 10, because 0 through 9 is 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember that 0 index. That's why I use the 0 index in here, so it matches how Python works. While this is true, you still use the colons, and then I'm just going to say print X. Okay, every loop I want you to print X. Now I also got to do this, otherwise it'll stay in the loop forever. I got to update the counter. If I don't update this counter, it will run forever. It will never stop. So let's see this action actually happens. If I run this line of code and shift enter, what you see down here is that it's running and it's constantly, and this thing will keep doing this until I run out of memory. Eventually my computer is going to run out of memory, and it's going to cause my computer to crash. When this happens in Spider, you have this little stop button. This interrupts the kernel. The kernel is where this processing is happening. So when I click this, it will stop it. It interrupts what the crunching, what it's trying to do, and it stops it and releases that memory back into the computer. So you might make this mistake. I just want to make sure that you're aware of this mistake, that you think something is happening, and next thing you know, you walk away and come back and your computer done crash, and it's because something was running and you didn't realize it. So if you see this thing ever be red, that means it's actually running. And then I think Jupyter Labs, they have a little star. If that star is up, that little star that's right by the, especially if you're using a Jupyter notebook, that star lets you know it's still running on that line of code. The kernel is still active. So just make sure you always keep knowledge of that. All right, so to stop this from happening, we have to update this counter every loop as well. So it'll be able to update this, update this expression to let you know when the expression is true. So you know what? I want to, when I do this, I want to print out the counter too, so we can just see know what its state is every time. So counter is here. All right, so we should see the counter print. You know what? We'll print them side by side. We've done that. So let's put the counter in this loop. You could do it. You could leave it the way I had it. I just changed my mind how I wanted the counter. All right, so it's gonna print the counter, then with a space, then print the second number. So what I want to do here is say counter. All right, we just did up there, plus equal 1. So it's gonna update by 1 every loop. So now when I run this, it will just do it 10 times. Shift enter and look at it. You see it? So the first loop printed the counter was 0, and it printed Michael. Then once it got through the loop, the counter has changed. So when it comes back again, the counter is 1, Michael, 2, 3, 4, 5, 6, 7, 8, 9. And then after the 9th loop, when it checked to see if should it go back into the loop, it said nope, I've met it, and then it moves on to the next line of code. So there's a lot of different types of ways to deal with data, especially outside of the base Python, which is what we're covering. But I would say for the most part, the for loop, if and else, and the while loop are probably the main 3 control structures I use in code for most part. I mean, I do use switch statements every now and then, but a lot of times I don't use those in Python. I use them in other languages. But for the most part, with those 3, you should be able to. You should be able to do very complex data analysis with those control structures that you know. You know everything you need to know to be able to manipulate different control patterns for your stuff. Okay, so I actually think that's it. That has covered everything I wanted to cover in this video. Again, we started with assigning just basic variables. We talked about how to add, subtract, multiply, and divide strings and integers. So number data types, numeric data types, and strings, which is an object type. We talked about the comparison operators and how those comparisons either going to out you back some type of Boolean that's true or false. And then you can use those comparison operators as conditional expressions for if-else statements or while statements. This expression returns back one of those Booleans, and based on if that expression is true or false, it will determine which branch of the code to go to. I keep calling it branches because that's what it's called in assembly languages when you do branch statements. But it's pretty much saying check this condition and then branch to a memory location and retrieve that information from that location. So that's the reason why I keep using that word. So that tells it which one of the branches to go through. And then we showed an example of assignment operation and how to do the quick hand for that. And then an example using the modulus just to show you the value of the modulus. It has a lot of value. And then how to set up a while statement if you want to loop through your data one at a time. Again, thank you for watching this tutorial. I hope it was helpful. I wish you a great day and enjoy programming. See you next time.